The video prior to this was solving absolute value equations. Now we're going to look at solving absolute value inequalities. The idea is the same. Of course, you have a complicated math definition of absolute value inequalities and what it means. Just remember, absolute value is distance from zero. So just like when we had equations, we have to consider the positive and negative distance. There are going to be some special cases of absolute values that I'm not going to do in class this year. We just can't get that far into it. And I'll explain those as we go along. But the idea is the same. If you have an inequality, you need to isolate the absolute value expression, and that involves just adding or subtracting numbers on either side, dividing out any multipliers until your absolute value expression is completely isolated. Then you have to write two inequalities, and again, once to the positive and once to the negative. But when you set it to the negative, the mathematical stuff up here is explaining to you in order to do that, you're basically multiplying both sides of an inequality by a negative, which means you have to flip the sign. So there's a little extra thing to think about on inequalities when you set up two equations, once to the positive, but when you set it to the negative value, you're going to have to flip the sign as well. Then you just solve the inequality like we were solving inequalities in the prior lesson with linear, and sketch a number line. We do need to sketch a number line solution for these. So I've got two examples worked out for you here just in print. These are straight from the textbook with their number line solutions. Again, isolate the absolute value, set up your two once exactly like it looks with the absolute value bars removed, once set to the negative value with the sign flipped. Solve it and write your solution. The textbook recommends that if you've got an inequality like this, where the solution is shading in between two values, you really express it as a compound inequality. They solve it as a compound inequality, but I don't. I solve the two individual, and I don't state the compound inequality until I get my number line sketched, and you'll see how that works. So let's look at these examples. First one, absolute value, just straightforward. Absolute value of x minus 2 is greater than 3. I think when we did the equals to, we had it equal to 3. Let's see what happens when we have it greater. All right, absolute value is isolated. We're good. So all I need to do, I can remove the bars, but I have to set up two inequalities. One is set up just, and I didn't even remove the bars. One is set up just like it looks with the bars removed, if I could do that correctly. Just with the bars removed, just like it looks, greater than positive 3. But then we have, and this one I am going to put an or, because sometimes they don't always end up as a compound, they end up separately. I'll fix it at the end when I do my answer. Or I could have x minus 2 with the bars removed, except we have to flip the sign and set it to negative 3, the opposite. So you flip and do the opposite. Then you solve your inequalities. We're going to add 2 to both sides, so x can be greater than 5. Or if I add 2 to both sides here, negative 3 plus 2 is negative 1. So x is less than negative 1. So I go to my number line. I'm going to mark off negative 1. Almost wrote negative 2, negative 1, 0, 1, 2, 3, 4, 5. I know x can be less than negative 1, not equal to, so that's an open circle shaded to the left. X can also be strictly greater than 5. Open circle shaded this way. If you see that your shading does not meet up in the middle, you cannot write it as a compound inequality. And it doesn't make any sense for a number to be and less than negative 1 and greater than 5. So I'm going to keep my or, and it looks like this work is good to box in. But honestly, sometimes I don't even box these in, because this is the answer that most people, look at when they're double checking these. You technically should go back and check these as well. Plug in a 5 and make sure it's true. plug in a -1 and make sure it's true, but on the inequalities, I am not going to give you any tricks or any ones that do not check out. The ones that are not going to check out for future reference, I might write it on the bottom just down here, just so you know. If you end up with an absolute value expression, whatever it is, if you have less than some negative number, I'll put a negative constant. Absolute values have to always be positive. They can never be less than, you can even have an equal here, a negative number. That would be no solution. But the opposite is absolute value of x minus 5 greater than some negative constant, some negative number. Absolute values are positive. They're automatically greater than a negative number. Always, always, always. So this would be all real numbers would satisfy that. Any x, if you subtract it from 5, it's going to be greater than any negative number. And it depends on the numbers, but in general, this is your special cases. When you have a negative on the other side of the inequality, I'm not going to do that to you on these lessons, so you don't have to worry about those. All right, back to the easy ones with solutions, or not infinite solutions. All right, this one has a negative on the other side of the inequality, but it's okay because I haven't isolated the absolute value yet. So when I isolate, I'm going to start talking faster so this video is not as long. We're going to add 3 to both sides. I'm going to have absolute value of x plus 2 less than or equal to -1 plus 3. 3 minus 1 is 2. I've got a positive value over here on the other side of the absolute value. There's nothing to worry about. I just have to do my 2 equations, or my 2 inequalities. One is going to look just like this with the bars removed, x plus 2 less than or equal to 2. The other one is x plus 2, remove the bars, flip the sign, and negate or do the opposite of your constant. And then once you do that, they're pretty easy to solve. You subtract 2 from both sides, so x has to be less than or equal to 0. On this side, if I subtract 2, minus 2, minus 2, x can be greater than or equal to -4. So let's go write the solutions. I'm going to have -4 on here, -3, -2, -1, and 0. And usually I just mark the numbers that I'm concerned with in the problem. I know x's can be greater than or equal to -4. And I can already start to shade. If I start shading this way, but also pick up this less than or equal to 0, less than or equal to 0 is this way, the shading is going to meet up in the middle. When your shading meets up in the middle, this answer can be expressed as a compound inequality. I didn't solve it as a compound inequality like the book did. I just did it like I always do, my 2 inequalities, but I noticed the shadings meeting up, which means my x's live between -4 and 0, and I can be equal to both of those values, so I'll put my equal sign, and there is my compound inequality answer. So that's going to happen when your shading meets in the middle. If your shading does not, it's 2 separate answers. All right, last examples. This one's a little more complicated inside the absolute value bars, but that's okay. I just need to isolate that expression. So to do that, I'm going to subtract 1 from both sides. I've got absolute value of 5x minus 2 is greater than or equal to 4 minus 1, which is 3. I've got a positive value on the other side of the absolute value. Beautiful. So I don't have to worry about any tricks. And that's again on these. That's why I'm not checking my answers. All right, so it's isolated. Remove the absolute value bars and write the inequality, 5x minus 2, greater than or equal to 3. But then write your second one, 5x minus 2 can be less than or equal, flip the sign, and flip the sign on the number as well, -3. Solve the inequality. We're going to add 2 to both sides. I get 5x is greater than or equal to 5. If I just add 2, and then we'll divide out our 5. X can be greater than or equal to 1. Let's see what happens over here. If I add 2 to both sides, I get 5x less than or equal to -1. Divide by 5, and x is less than or equal to -1/5. All right, so here are my two answers. I'm just going to leave it as -1/5. So I've got I'm going to mark off 0. I've got +1 here that I'm marking off. I might as well put my closed circle. And x can be greater than or equal, so that's going to be shading that way. It's less than or equal to -1/5. -1/5 is going to be real close to 0 here. So I'll just mark -1/5. It can be equal, and less than gets shaded this way. So it doesn't look like my shading's going to meet up. I got one going this way. Oops, I have a little gap, and the rest going this way. So it looks like I've got an or statement for my answer. And again, I'm boxing this in, but I don't necessarily have to because I have my number line, but it's good for the reader to be able to find it. I definitely did it up here. All right, last one. Again, absolute value, -4 less than 1. So we're starting with a less than on this one. We're going to add 4 to both sides. This one might be a little restrictive because it looks like I've got to be less than a number. Remember, absolute values are always positive, so when they're less than, sometimes you're restricted. 4 plus 1 is 5. All right, it's the absolute value has a positive on the other side here, so we're good. Remember, we only have to worry about these negatives on the other side. When it's an equation, I need you to watch for that and check it. When it's inequality, there's too much checking involved because there's a bunch of different possibilities. We're not going to worry about that. All right, so I've got the absolute value isolated. I'm going to write my two equations. Inequalities, sorry, two inequalities. 2x plus 7 is less than 5 is one of them. The other one is 2x plus 7 is less, oops, I forgot to flip my sign. See, it's easy to make mistakes. You have to flip it to greater than -5. All right, add 7 to both sides. 2x is less than 12. Divide by 2, x can be less than 6. On this side, if I subtract 7, 2x is greater than -12. Again, -7. -7 minus 5 is -12. I'm not going to divide, I'm dividing a negative number, but I'm not dividing by a negative, so I do not need to flip anything. Again, x can be greater than -6. So less than +6 and greater than -6. Something went wrong here, didn't it? I know what I did. I added 7 instead of subtracted. I made a mistake, but at this late in the video, I'm just going to fix it here. I bet some of y'all saw that as I was doing it. -7. I knew those answers were too far apart. Something didn't look right. I'm supposed to subtract 7. 5 minus 7 is -2. I'm sorry, guys, but I'm not going to start over because I'm at the end here. Divide by 2. X can be less than -1. If I would have gone and checked my answers, I would have found it at that point too, but I knew just looking at it, it didn't look right. So x can be less than -1 or greater than -6. So I've got some negative numbers here. I'm going to start at -6 here, -5, -4, -3, -2, -1. I hope I counted right. If I can be less than -1, but strictly greater than -6, I'm going to meet up in the middle. So, I mean, technically, these answers are good, but I'd like you to recognize that this could be a compound with x greater than -6, but less than -1. All right, so that is the end of the inequalities. Again, you should check your solution so you don't end up with something like I almost made the mistake here, but I'm not going to do any tricks for you on the inequalities, especially on this case, because you have to really check and make sure that's true. I made kind of a bad example, so. All right, I'm going to stop that, and your assignment will be posted on Blackboard.